All right, so we are going to wrap up our unit on radicals, and this is going to be a bit of, not a review because we technically haven't done it before, but we did use this when we were solving square root problems when we were working on quadratics. So when you are looking at a radical equation, remember the difference between an equation and an expression is that an equation has a what? Equal sign, which means you can solve it. So an equation is solvable because it has an equal sign. You cannot solve an expression, you can only simplify it. So like in the problems that you guys just did on the board in the rewind, none of these were solved, right? You didn't have like a y equals something, but all of them were simplified, which means what? What's the difference between simplifying and solving? Simplify is like making it smaller. Solving is you get an answer. You get a number value for a variable, right? So x equals 2 or x equals 7 or 8 or whatever the possibilities are. There's a lot of possibilities, but it means you have an answer to something. So when you have a radical equation, you can solve it because you can use inverse operations to get the variable by itself. What is the inverse of a radical sign? So again, inverse meaning opposite. What's the opposite of a square root? Squaring something, right? The little exponent of what number? 2. Little exponent 2. So remember when we did this when we were solving quadratics, solving square root functions? So when you have a square root sign, a radical, to get rid of it, you square both sides. What happens when you square a square root? It just disappears, right? And all you have left is x. And then when you do 8 squared, what do you have left? 64. So x must equal 64. And if you plug that back in, it makes sense, right? Because what's the square root of 64? 8. Good. Okay, so then what would I do here? What would I do here? Brendan?
You would take away the square root.
I want to get rid of the square root first. I have to get rid of that before I get rid of the, what else do I need to get rid of? I don't want to get rid of the x.
The coefficient of 4.
The coefficient of 4, but how come I have to square it first?
Because then if you get rid of the coefficient of 4, you have to square like in the end.
Yeah, you're following proper order of operations. Yeah, if we're following proper order of operations, we get rid of that before we get rid of the multiplication, okay? So if I square both sides, what happens on the left side? 36. And then what happens over here?
4x.
Just 4x, because the radical disappears, right? Okay, so then what would I do to finish this?
Divide by 4.
Good. Divide by 4, divide by 4, and x must equal, close, 9. Good. X equals 9. Okay, so solving radical equations is just like solving every algebraic equation we've been doing since August. It's just recognizing that to get rid of a radical, you have to square it. All right, so squaring it just makes that disappear. All right, what if you have something like this? What's the difference between this and the one we just looked at?
The x is the radical.
The x is the radicand, right? It's inside. And then what else? It's got a +3 where? On the outside. So what do we get rid of first here? We have to get rid of the 3 first. So you have to, before you can square it to get rid of the radical, you've got to get the radical by itself. All right, so to get that by itself, how do we get rid of a +3? Yeah, -3 minus 3, which gives us 7 equals square root of, and now what do I do? Now I square it, so that'll get rid of the radical on this side, and I'm left with just x equals 49. Perfect. Okay, so before you get rid of the radical, you need the radicand just alone. All right, you need the radical by itself. So in B, do I get rid of the 5 first or the radical first? I get rid of the radical first. How come I get rid of the radical first here? Because the 5 is part of the radicand, right? So the 5 is part of the radicand, which means I have to get rid of that before I can get rid of the 5. So how do I get rid of the square root? Square it. I square both sides, and I end up with what on the left side? X minus 5, so the entire radicand, right? Because it just basically makes the symbol disappear. And then what does this give me? And then what do I do? Add 5. Very good. Add 5 because I inverse operations on that. And x equals 21. Very good. Okay. Here there's a bunch of stuff. What's the first thing I have to get rid of, Brendan?
The 4.
The 4. Why?
Because it's outside of the radical.
It's outside the radical. So how do I get rid of a plus 4? And you end up with what?
3.
Equals what?
Radical 2x.
Okay, now what do I get rid of?
You give the radical.
Now I get rid of the radical. How come now is the time where I have to get rid of the radical? Yeah, everything else that's left is inside the radical. So I have to get rid of the radical, so I square both sides. And I end up with what on the left side? Yeah, just the entire radicand. And then what over here? 9. Now what? Yeah, now it's just your basic 2-step algebra problem. So 9 plus 1 is, and then that equals 2x. And how do you finish that? Good. So x must equal, good, great job. Okay, so I think these are kind of a nice little detour because they're pretty simple. It's very similar to what we were doing at the very beginning of algebra. We're just sticking in one more type of math, one more inverse operation. Whereas before we would always either use plus, minus, add, or divide, plus, minus, multiply, or divide. Now we're just adding in an exponent. Brennan?
Is there like a catch or anything?
There usually is, isn't there? I don't think there is, to be honest with you, today. There's one catch when we do division, and it's not really a catch, it's just something people always forget. But no, I'm not throwing any curveballs at you. Okay. When we're multiplying and dividing, what am I going to get rid of in A? What do I have to get rid of? The 3, and the 3 is outside the radical, so I have to get rid of that first. What kind of math is it here? Multiply. How do you know that? There's no symbol. It's right next to each other. It's touching in, there's no symbol, so you know it must be multiplication. So how do you get rid of it? Divide by 3. So then radical x equals 7. And then what do I do? Square, square, and x equals 49. Perfect. Okay? Still no curveball, right? So to get rid of multiplication, we still use what? Okay, good. So then down here in B, this is my only mild curveball. What kind of math is this? Division. How do we get rid of division? Multiply. For some reason, people always forget that. I think because it looks like fractions, and as we know about ourselves, as soon as anything remotely looks like a fraction, people freak out. But remember, to get rid of a fraction, you just multiply by the reciprocal. And in this case, the reciprocal will be 3 over 1. Okay? So multiply by 3 or 3 over 1, however you want to think about it. What happens with those 3's? They go away, and what do you have left? It's x over 1, but do you need that one? Not really. And then what do you get over here? 15. Again, 15 over 1, but do you need it? No. Okay, and then how do I finish? Square it. And x must be 225. Very good. 225. Okay? So no curveballs. It's just about remembering that to get rid of division, we multiply by the reciprocal. Okay? And that's just something that people always forget. All right, go try these 9. Okay, so when you are looking at a radical equation, sometimes they will have square roots on both sides. If you have a square root on both sides, what do you think you do? What do you think you do? Brendan? You what? You still square it, right? Because you still have to do what with the radicals? Get rid of them. So if I square this and I square this, what happens to both my radicals? They go away. So really, what do I have left? Equals 3. Good. And then how would I finish that? So x equals 2. Perfect. Okay? So if there's a square root on both sides, you still square it. What about here? What's happening here?
Well, they're on the same side.
They're on the same side? Do I want them on the same side? What could I do to get them on different sides? What could I do if I wanted it to look more like A looked? Rodrigo?
You add one of them?
Yeah, which one?
3x.
Yeah, why would you add the 3x instead of this one? Yeah, you make it positive if you get this by itself. If you move this one, it makes it negative. So plus root 3x plus root 3x. And then you end up with what's on the left side now? X plus 8 in a radical equals radical 3x. Because we moved it from that side to the other side. And when we moved it, it changed signs. Okay, now what do? Square both sides. And what do you have left? X plus 8 equals 3x. Good. How would I finish? I've got x's on both sides, so what do I have to do?
Like terms.
Yeah, collect your like terms. So George, what do you want to move?
The x.
This x by itself, right? Because how many x's is that? If there's no number, it's 1, right? How do I move a positive 1? Yeah, make it a negative. So minus 1x, minus 1x. And then what do I have left over here? 8 equals, what's 3 minus 1? Good. And then how do I get rid of that 2? Divide. Good. Divide by 2, and you get x equals 4. Perfect. Great job. Okay, so if both of your radicals are on one side, you can move one to the other and then get rid of both of them in the same step. All right, now, my only curveball is extraneous solutions. So extraneous, does anyone know what that word means?
Weird.
Kind of, yeah. It basically, if I say something is extraneous, that means it's unnecessary or it doesn't work. So an extraneous solution would be something that isn't actually a real solution. So when you do these radical problems, you've got to plug them back into the original equation to make sure that they work. Because remember, what can you not take the square root of? You cannot take the square root of a...
0.
You can take the square root of a 0, Ollie. Negative. You can't take the square root of a negative. So when you do these problems, you have to make sure that none of your solutions end up giving you a negative. So we'll look at an example that will look like that. So take a look here. What's happening here? We've got radical 6 minus x equals x. So how do I get rid of the radical here? So if I square that and square that, what happens on the left side? So I just have 6 minus x, and then what do I have here? X squared. Okay. So now what do I do?
Add it to both sides.
Add what to both sides? Add the x to both sides, I agree. Plus x, plus x. Can you combine those? No, because this one has a variable and an exponent, and this one's exponent is what? 1. So I write x squared plus x equals 6. Okay. So starting to look like a what? Starting to look like a what kind of function?
A trinomial.
It kind of looks like a trinomial, like a quadratic trinomial. Only if I want to solve a quadratic trinomial, what do I need it to be equal to? 0. So what do I have to do with this 6? Well, I'm making a negative 6 and move it over here, right? So now I have 0 equals x squared plus x minus 6. Now that it's a trinomial, I know everybody remembers this because we have finals coming up. So every trinomial, when you go to solve it, splits into 2 what? Binomials. And this one's a simple one, right? Because it doesn't have a coefficient. So that means what are my first 2's? X and x. And then how do I figure out the numbers?
What times what equals what
Times to get 6, and it has to add up to what?
1.
1. Why 1? Where are you getting 1 from?
X has an invisible.
Yeah, it's like an invisible 1. Okay, so what multiplies to 6 that adds to 1?
3 negative 2.
3 and negative 2. Good. So plus 3, negative 2, because that gives me a negative 6, and then positive 3 minus 2 gives me 1. Okay, so then what are my actual answers?
3 and 3. Would it be positive 3?
It would not be positive 3. Negative 3 and positive 2. All right, negative 3 or 2. Now, yeah, you go under it and you subtract. So you say basically what are the opposites of these? Because remember, I want to make it equal to what? 0. So what's negative 3 plus 3? 0. And what's 2 minus 2? 0. So that's how you get your actual answers, right? But remember that we need to do what with these to make sure they're not extraneous? Plug it back in. So I'm going to plug in negative 3 or 2 to my original equation. All right, if I plug in negative 3, 6 minus negative 3. So what's 6 minus negative 3? What happens with these two minuses? Plus, and I get square root of 9. Can the square root of 9 be negative 3? Am I taking the square root of a positive?
Yeah.
I'm allowed to do that, right? Can negative 3 times negative 3, what does that give me? Positive 9. So does that work? Yes, so that one works. Okay, now the other one was 2. What's 6 minus 2? 4. So the square root of 4 equals 2. Is that true? Yes, 2 equals 2. Therefore, that worked too. So there were no extraneous solutions here. So this worked. Okay? But remember, when you take the square root of a negative, if it were negative in here, then would that work? No. So that's when you would say no solution. Okay? Or if this one worked but that one didn't, then this is your only answer. Okay? So you have to go back and plug them in. Do you have to do that all the time? If they're not like trinomials, it's probably not going to happen. Most of them are simple. Like the ones you guys just did on the board, you don't really need to go back and plug in, or you can do that mentally. All right, but when you have one that ends up being a trinomial, then you probably need to. How do you recognize that it's going to be a quadratic trinomial? ABC, that doesn't look anything like ABC though, so you're going to have to recognize it earlier than that. So what's kind of like the flashing light that tells you this is going to be a quadratic you might need to factor? X squared. As soon as you see that x squared, you know you're probably going to have to get it in ABC format so that you can break it into binomials. I will tell you, none of them are going to be more complicated than like, I won't give you a coefficient for these. Okay, so it'll just be x squared. All right, try these. The first two are just with both sides. The next three, make sure you check your answers on those. Go ahead.